Pre-Algebra Lesson 1-6, Subtracting Integers. Just as we can use tiles to add integers, we can use tiles to subtract integers as well. Let's take a look at a couple of these. Again, you can just use red and yellow colored pencils, or you can use plus or minuses within squares to make this so that you can show your positive negatives. If I have a -7 and I'm going to subtract from that -2. So let's start off with 7 negative tiles. 1, 2, 3, 4, 5, 6, 7. And now it tells me to take away from that 2 negative tiles. It says -7 minus a -2. So it says take -2 tiles away from that. So I can take 2 tiles away. Okay. Both of these 2 tiles go away, and I am left with -5. Now, if you want to show this, because you don't have a little garbage can to make them go into here, you can show this by saying, okay, now I'm going to take away 2 tiles. You can simply circle them and take them away, show that you're moving them away. And what are you left with? You're left with 5 tiles. Okay. Let's take a look at the next problem. The next problem here says -4 minus -3. Okay, so I'm going to start with 4 negative tiles. 1, 2, 3, 4. And I'm going to take 3 of those away. I'm going to take 3 of those tiles, and they're going to go bye-bye. Which means I'm left with 1 negative tile left. So -4 minus a -3 happens to equal -1. Problem number 3 here, it says take -8 tiles. So start off with -8 negative tiles. 1, 2, 3, 4, 5, 6, 7, 8. And take away 5 of them. Okay, so I'm going to take away 5 of those negative tiles. 1, 2, 3, 4, 5, those go away, and I'm left with 3 negative tiles left. Okay. Now, if we look closely at this, we might start to see a pattern here. Let's look at 2 more problems, and then we'll see if we can figure out the rule for subtracting integers. Okay? So, let's look at number 4 here, which says take 4 positive tiles, and then you're going to take away 8 from that. So here I have, I'm going to bring, whoa, I did it again. I'm going to take away 4 tiles. I'm going to take 4 positive tiles, excuse me. 1, 2, 3, 4. And from that, I'm supposed to take away 8 positive tiles. I can't take away 8 positive tiles because there's only 4 positive tiles there. That's like me coming up to you and saying, give me $10 if you don't have $10. It's actually impossible for you to give me something you don't have. I cannot take away 8 tiles here because I don't have 8 tiles. But what I could do is I could add 0 pairs. A positive and a negative make 0. So if I added a positive tile and a negative tile, I didn't really add anything because I added 0, didn't I? Positive and negative is 0. I'm going to add another positive and a negative. And then I'm going to add another positive over here and a negative. And then I'm going to add another positive and a negative. So now I still have 4 tiles because positive and negative here, this becomes 0. Whoops, didn't lock that in place, that's for sure. Holy crap, let's do that. Lock this in place really fast. It doesn't live on me anymore. There we go. I can pull these back. Alright, so now if you look at this, can I take away 8 positive tiles now? Yeah, I can, can't I? If I wanted to take away 8 positive tiles, I can simply just cross out 8 positive tiles, can't I? 1, 2, 3, 4, 5, 6, 7, 8. What am I left with? negative 4. So 4 minus 8 is negative 4. Let's take a look at problem number 5. It says 1 minus 5. So I have 1 positive tile. And I'm supposed to take away 5 positive tiles from that. I can't take 5 positive tiles away because there's not 5 positive tiles there. So what I have to do is I have to add 0 pairs. Here's adding 1 0 pair. Here's adding a second 0 pair. Here's adding a third 0 pair. Here's adding a fourth 0 pair. And here's adding a fifth 0 pair. So I essentially added nothing, because I added 5 0 pairs. But now can I take 5 away from this? Yes, I can. I can now take 5 yellow tiles away. 1, 2, 3, 4, 5. Okay? Which means this is a 0 pair. This doesn't mean anything. I added 1 too many 0 pairs. What am I left with? I'm left with 1, 2, 3, 4 that are negative. So this makes negative 4. Hopefully what you're beginning to see is you're beginning to see that there's a pattern to this. Okay? You're beginning to see that, wait a second, I see this. If I take a number and I subtract it, that's the same as adding its opposite. Because what's the same as subtracting 5? It's the same as adding a negative 5. Okay? So I added a negative 5 to it. What's the same as subtracting 8? It's the same as adding a negative 8. So essentially what we can get to here is we can get to the rule for subtraction, which says to subtract an integer, add its opposite. Think, keep, change, change. Keep the first sign, keep the first number and its sign. Okay? Keep the first number and sign, change the sign, change the, okay? Keep, change, change means this. And if I have 3 minus negative 5, keep the first number. Change the subtraction sign to an addition sign, change the very next sign. So this would become 8. Okay? Keep, change, change. To subtract an integer, you're going to add its opposite. Think, keep, change, change. Then all you're going to do is apply the rules of addition. So we're going to take all of these numbers here, these problems here, we're going to change it to addition problems. Every single one. Even if you think you can do this in your head for now, I want you to change these to addition problems so you get into the habit of just doing it, and then naturally you'll start to pick up on how to do addition and subtraction. Okay, so here we go. This is going to be negative 7. Keep, change, change. Okay? Keep, change, change. Okay? Negative 7 plus 4. 2 different signs. We're going to subtract them. So 7 minus 4 is 3. This would be negative 3 because 7 is larger. And if I wanted to, I could take 7 negative tiles. If I took away 4 negative tiles from, say, 7 negative tiles, 10 negative tiles. 1, 2, 3, 4, 5, 6, 7. If I took away 4 of those negative tiles, what am I left with? 3 negative tiles. There you have it. Okay, simple as that. You can do it. It's just harder to do when the numbers get bigger. Like number 2. 23 minus a negative 5. Remember, let's change this to an addition problem. Keep, change the subtraction to an addition, change the negative 5 to a positive 5. Keep, change, change. It becomes 28. Because I'm supposed to start with 23 positive tiles, and I'm supposed to take away 5 negative 5 tiles from 23 positive tiles. So I would have to add 5 0 pairs, wouldn't I? And then when I take away those 5 negatives, I added 5 positives to them. Let's look at number 3, negative 40 minus 66. Keep, change, change. Keep the first number, change the subtraction sign to an addition sign, change the 66 to a negative 66. Keep, change, change. It's really nice and easy to do in your colors. So, same signs, we're going to add them together and keep the common signs. So 66 and 40 is negative 106. Because when we add them together, that's what we get. 2 minus 34. Keep, change, change. Keep, change, change. So 34 minus 2 is 32, and it's going to be negative 32 because the 34 has a larger absolute value. go. Number 5. Don't ask me why I have any trees. 6 minus a negative 2. Keep, change, change. So it becomes 6 plus 2 is 8. Negative 6 minus a minus 5. Keep my negative 6, change my negative sign to a positive sign, change my negative 5 to a positive 5. So negative 6 plus 5, signs are different, so subtract them. 6 minus 5 is 1. It's negative 1 because the 6 has a larger absolute value. 3 minus a negative 5. Keep, change, change. Becomes 3 plus 5. 3 plus 5 is 8. 12 minus a minus 12. So I'm going to take 12 positive tiles, and I have to somehow take away 12 negative tiles from those 12 positive tiles. And the way I can do that, I have to add 0 pairs until I have 12 negative tiles to take away, which means I'm going to actually add 12 positive tiles. So 12 plus 12 is 4. The more you work with these, the better you get at them. You just have to learn the rules, and the more you work with them, the better you'll learn the rules, and the more familiar they'll become, and pretty soon this will become second nature.